This is the homework helper for Chapter 3, Section 2 in the workbook, Graphing on the Coordinate Plane. A lot of where we're about to go here in this set of lessons is into coordinate graphing and things that relate to the coordinate plane. So it's a good time to make sure we're familiar with all the ideas behind this before we jump into those geometry type concepts that involve the coordinate plane. So at the top part there, they're asking me to give the coordinates and the quadrant of each point. Remember, the coordinates are an x number which comes off the x-axis that runs from left to right, and then a y number, that's the one that runs up, down, or north, south. We'll find the pairing that relates the x and the y number and write that as our coordinate x, comma, y. The quadrant simply refers to which sector the graph is in. The upper right one that we use for a lot of things here, for instance, bar graphs and line graphs usually, that's quadrant 1, and then the numbering goes counterclockwise, 2, 3, and 4. It is also possible that a point could be on the x-axis, on the y-axis, on the origin, which is at the crossbars, or, for instance, if it was on the positive part of the x-axis, you could say it's between quadrants 1 and 4. So, let's keep that in mind here as they're asking us to, in this first part, give the coordinates and the quadrant of the point. Now, one thing I want to make sure you notice here in 1 through 8 is that the graph here actually goes by 2s. I know it's actually numbered by 4s in that it goes 4, 8, but notice there is a blank in between each one that would represent 2. So this would be 2, 4, 6, 8, 10, so on and so forth. So for instance, if it's between 4 and 6, then the number that they mean is then 5. Okay. So when we're taking a look at point F, which is over here, that's actually in negative territory for the x-axis right here at -2. And you can see the y point that corresponds with it is between, in this case, what would be -2 and -4, which is, of course, -3. So the coordinate there for F is going to be -2, comma, -3. And when they're asking where is the point, that is quadrant 3, this lower left quadrant. Let's try one more of those. I think they're pretty basic, but we'll take a look at just one more. We'll take a look at number 4 there, which is point B. Now in point B, the x number that it matches up with is over here between 4 and 6, which is of course 5. The y number this matches up with is actually labeled right on the graph at -4. So if the x number is 5 and the y number is -4, the coordinate then is 5, comma, -4. Remember, coordinates are always written x, comma, y. And since that is in this lower right sector, that is in quadrant 4. Now, the directions for 9 through 14 are just kind of backwards here. Instead, what they're asking us to do here is to work the other direction now. They're going to give us the coordinate, and you're going to have to graph the point. What's a little bit different here is that some of these have fractions or decimals in them, but don't let that throw you at all. It doesn't really change a whole heck of a lot. If we take a look at number 9, where they're asking us to graph A, 2.5, comma, 1, the first number again represents the x-axis representation. So 2.5 in this case would be between 2 and 3. Notice the graph is now going by 1s as opposed to 2s up top. So 2.5 is going to be between the 2 and the 3. And the second number there is a 1. That means on the y-axis the number is 1. And I'm going to put my fingers on those x's and just pull them together to where they meet. And that's where that point is going to be on the coordinate grid. If I were to ask you a follow-up question, which quadrant is that point in? Well, of course, that's in quadrant 1, because anything in this upper right quadrant, whether it's here or way up here, is considered to be in quadrant 1. Let's take a look at question 13, a little bit different, -2 1/3, comma, 0. So the x number that's represented there is -2 1/3. So on the x-axis, I need to figure out where -2 1/3 is. So what you want to do here is go to -2 and then just scooch a little bit more to the left, and that's going to be -2 1/3. You don't want to go quite halfway, because we know what that is. Between -2 and -3 is -2.5. And negative 2 1/3 is a little bit smaller than that, so we want to make sure we want to be a little bit to the right of halfway still. And if you're having problems seeing that because there's just so much on that little graph there, cover up the stuff north and south there. And realize all that is just a number line. You know how to use a number line. The y representation there is 0, so we don't have to go up or down for the y number. So where I drew that little x for negative 2 1/3 is actually the point here for question 13. That is point E. Okay, and now finally down at the bottom of the page there, they're asking us to find the distance between the pair of points there. And in question 15, you'll use the same idea in 16, 17, and 18. But in question 15, they're asking me to find the distance between A and B. Now, there is actually a distance formula here, but one thing you will see, and it's very clear if you connect the points, is that these are pretty much all straight line type things. So what you can do here really is just count the number of jumps when you connect the points to find that distance if you really want to. So between A and B is just a thing that runs north-south, and the only other thing you have to see here to be successful is that every jump represents 2 here. So when I count my jumps from A to B, I'm going to see 2, 4, 6, 8, 10, 12, 14, 16. So the distance between A and B is 16. Now, what they suggest here in the book is that you actually find the distance by using subtraction here. Since these are not diagonal lines, as in lines that don't run horizontal or vertical, you don't really need to use the formal distance formula, which you'll see later on. You can really just subtract. Now, take a look at the coordinates here. Negative 4, 8, and negative 4, negative 8. What you wouldn't want to do is subtract the two that are the same, because that would always go to 0, and that's never going to get you anything, because clearly that distance is not 0. So what you want to do is subtract the two that are different. You're going to subtract 8 and negative 8. Well, 8 minus negative 8, no surprise to you, does change into 16. You get the same answer as when we counted the jumps. And once again, I'll restate that when we counted the jumps, because the graph goes by 2s, we see here 2, 4, 6, 8, 10 going up. We make sure that each jump represents 2, and that's why I went 2, 4, 6, 8, 10, 12, 14, 16 when I derived my final answer.